Alright, so AC methods, as I said, instead of applying potential over time like we do here in the DC method, now we're going to apply a potential really close to the OCP, but changing the frequency of the AC current polarization. Okay, so we alternate the polarization, and then we, in response, have an alternate current. Okay. So the response that we get from it is the capacitance, the resistivity, and the inductance of the system. Okay, so you can have capacitors, inductors, and resistors. In our case, we're just gonna work with capacitance and resistance. Why is that important? Because this is controlling how the electrons will flow in your system. Okay, and when you have the measurements of how these electrons will flow, you can understand and create mechanisms to the corrosion process of these alloys. Okay. So as I mentioned here, the parameters we're going to change is the voltage and the frequency from higher frequencies to lower frequencies, and measuring the capacitance and the resistivity. Okay. So here we have some typical spectra that you can find in a system. Okay. So this one here, the first one, is a capacitive behavior, because your impedance, your imaginary impedance, is growing as the same time as your real impedance. Okay? When you go this way and you don't close the semicircle, it means that you have a lot of capacitance happening. Here, when you close this completely, you have two scenarios, right? The first scenario is where you have a bare sample and you just have one resistance in the system, which is your AA resistance. Or you have something that is between the sample and the electrolyte, then you have your coating resistance. Okay? In that case here, you have two semicircles, and these semicircles will represent where you system where you have both the AA capacitance and resistance, and also the coating resistance. In this case, is when your coating has a damage. So if your coating is damaged, the potential set will get two kinds of signal: the signal from the exposed sample and the signal from the coating. That's why there are two semicircles. Okay? This one here is one case where you have one semicircle and a 45-degree angle going up. That represents diffusion control, meaning that even though you're exposed, your sample is exposed, there's a diffusion control mechanism taking place, which means that the ions have trouble getting to the reaction site.
It needs time.
Huh?
It needs some time to diffuse.
It could be time, or the temperature, or maybe agitate your solution. It depends, or may even not corrode because ions cannot get there. Okay? So these are the spectra we're gonna get from the test, right? But they are quite hard to understand and quite hard to study. So what we do is we get equivalent circuits to try and understand and represent what's happening, right? In this case here, there's two cases. You have the solution resistance, and then you have in parallel a capacitor and a resistor. Okay? In that case, it could be the AA capacitance and the AA resistance, or the coating resistance and the coating capacitance. How would you differ them? How would you differ, like if you this equivalent circuit I'm saying is for the uncoated and for coated sample? How would you differ them? What would be the difference? Any idea? What do we measure here? We measure impedance, right? And impedance is just a complex way to understand the resistance to polarization of these alloys. If we have a coating that is no conductive, it's a dielectric coating, that means that this impedance will be much higher than the one
like
that is
open
not.
circuit.
Huh?
Like an open circuit.
No, yeah, like an open circuit, that's correct. Yeah. So that means the impedance for the coating coated sample will be much higher than the impedance of the uncoded sample. So you may have the same equivalent circuit, but the values of these two are going to be higher than the uncoded. Alright? So now in the case of the scribed one, so if you have a damage on your coding, you now have two signals coming. One is from the coding and the other one is from the double layer. So therefore you have this typical circuit where you have the solution resistance, the coding resistance and the capacitance, and the double layer capacitance and resistance. That's why you have two semicircles, because you have two more elements in the system. Alright? So today we're gonna do the impedance test for one uncoated mild steel, a coated mild steel, and a coated mild steel with a scribe on the surface. So we have these three scenarios, and we're just gonna run the test to see how the curves are, okay? And we're gonna try to fit those spectra using this and the software.
Excuse me, I want to know, these two are all electro double layer? One is
no, this is the coating and this is the double layer.
For this one?
This one could be either the double layer
and either the coating. Okay,
yes,
got it.
because if you don't have a coating, it will be the double layer. If you have a coating and it's perfect, there's no water uptake and nothing connecting them, that will be your coating resistance and capacitance. Okay? Alright. So now let's go to these cells where we can do the tests. So now we're not doing the flat cell anymore. We're doing the 3-pin cell, which is this one here. You have your same reference. The counter electrode, now it's a graphene rod. And here is your working electrode, okay? On the bottom. And the solution is the same, 0.1. Also for this one, I'll come back here. So the impedance is measured in ohms, okay? Impedance is measured in ohms. But just ohms, again, doesn't mean anything. We need to normalize by the area. And the area of our working electrode is 15 centimeters square. Okay? So you use, that's okay. Use 15 centimeters square to normalize your values. The values you're going to get there are not normalized by area. You use this to normalize. Okay? So your resistance will be this, and your capacitance will be this. Okay? No, actually, no. It's Faraday. Okay? So make sure the units are normalized and everything will be fine. Alright. So group 1 can take this one, group 2 this one, and group 3 can go to the next one over there. Make the connections the same way. Working electrode is green, counter electrode is red, and reference electrode is white. Okay? Once the connection is ready, we can start the tests.
你 counter 是在哪儿？ counter electrode，counter electrode， 我看一下哈 ，counter electrode 下面。那我这儿连的应该是，我明白了，绿色的应该是连那个 working electrode 是下面。working electrode 下面这儿。 working 在下面是吧？counter electrode 是上面。Oh, sorry, I think 是这儿吗？ Oh no no.
This is not working.
Oh, sorry.
Connect here. So there's a scratch here.
Yeah, I see a scratch.
Yeah, in contact with.
Yeah, okay, it's done. Oh.
意思是一个人写的是